All right, in this final problem, we're looking at a reaction between aqueous magnesium bromide and aqueous sodium phosphate. And just like we did in 2A and 2B, here in 2C, I will go in and assign the charges to all the ions first. Magnesium's in the second column, so magnesium has a +2 charge. There's 2 bromides, so each bromide has a -1 charge. Sodium is in the first column, and so has a +1 charge, and there's 3 of those. And then PO4 is a 3- anion. Okay, and then I will write my metals in the same spot, same order, and switch the anions. So magnesium was with bromide. Let's put it with phosphate. And sodium was with phosphate. Let's put it with bromide. Now's the point that we need to check our formulas. Sodium bromide, of course, is okay, Na plus Br minus. Magnesium knows magnesium 2 plus, and phosphate has a 3- charge. You may have learned, and this works really well, to treat these as coefficients and do a sort of cross multiplication. And if we do that, we get 3 magnesiums, and I'm going to put some parentheses around here, 2 phosphates. Now we have 3 times 2 plus, so we have 6 plus from the magnesiums, and we have 6 minus from the phosphate. So now we have a neutral species. Finally, we need to decide which, if any, of these two will precipitate from the solution. So phosphate salts are usually insoluble. There's no exceptions to that except for ammonium, lithium, sodium, potassium, rubidium, and cesium. So it is the magnesium phosphate that precipitates out of the solution as a solid. Bromide salts are usually soluble, all sodium salts are soluble, and so this definitely stays dissolved in the aqueous solution. Finally, we need to balance this molecular equation. We need 3 magnesiums, 2 phosphates, and from that then I get 6 NABRs in one of those guys. Now we go in, and anything that's aqueous we write as separate ions. So 3 magnesiums, 3 times 2, so there are 6 bromides. 2 times 3, my 3's kind of gotten lost here, but 2 times 3, 6 sodiums, and 2 phosphates. Okay, and what's going to form is magnesium phosphate solid. And the other products are 6 sodiums dissolved in solution and 6 bromides dissolved in the solution. So we have 6 bromides as reactants, we have 6 bromides as products, we have 6 sodiums as reactants, we have 6 sodiums as products, and so we can do the thing if something shows up as a reactant and a product, we cross it out. And then what remains is our net ionic equation. So 3 magnesium 2 plus ions, aqueous, plus 2 phosphate 3- ions, aqueous, to precipitate out of solution as magnesium phosphate, solid.